In this lesson, we are going to talk about type 2 ionic compounds. They are very similar to type 1. In a type 2 compound, a metal will lose electrons, giving it a positive charge, and the nonmetal will take the electrons and it will form an anion, which is a negative charge. Positive and negative attract. So we're going to do the same kind of thing as we did in type 1. The big difference is in a type 2, the cation does not have a common charge. In our type 1 compounds, the cation always had the same charge. It was a common charge based on its position in the periodic table. In type 2, it doesn't have that. They tend to be transition metals, and they often have more than one common charge, which is the problem. For example, iron will form a positive 2 charge and a positive 3, and both of those are equally common. Other elements that don't actually fall into the transition metals are lead, tin, bismuth, and antimony. Even though they are in a column with a common charge, these elements have 2 common charges. So how do we know which charge to use? What chemists have done is they've created a system where we use Roman numerals to tell you what the charge is. And these are the Roman numerals you'll need to know. Make sure you distinguish between 4 and 6. And you won't have to worry about anything beyond 6. None of the elements we use go past that point. So the way you write formulas for a type 2 compound is, first of all, you identify the metal, just like before. Use the charge as given in the name, and it's always going to be a positive charge. So this would be called iron 2, iron 3, etc. Then you want to identify the anion, and you are going to use its common charge. That one will not change. Switch charges, that means drop and swap, and then simplify whenever possible. So let's practice. If you notice, all of these have Roman numeral written in parentheses in the middle. And that Roman numeral always refers to the first element written. So iron 3 oxide is Fe and O. Fe has a charge of 3. O from its common charge is 2. Drop and swap. Fe2O3. Chromium 3 chloride. Again, that 3 refers to chromium, which is Cr. Chloride is -1. Drop and swap. CrCl3. Gold 3 sulfide. Gold is Au. Be careful to distinguish that from silver, which is Ag. Positive 3 charge. Sulfur has a common charge of -2. Drop and swap. Au2S3. All right, the next one, manganese, be careful. Manganese is Mn, not Mg. That is a Roman numeral 4. Selenide is Se. Its common charge is 2. Drop and swap. However, this one can be reduced to MnSe2. That would not be an acceptable answer to have the 2 and the 4. Cobalt 1 nitride, cobalt is CO. Make sure that looks like a little o. That 1 is referring to the CO's charge. Nitride is N. Drop and swap. CO3N. Tungsten is a hard one to find. It's kind of down towards the bottom. That is Roman numeral 4. Carbide means it's coming from carbon, also 4. When I drop and swap, I get that, and that can be simplified to WC. This 2 is referring to the tin, SN. And if you notice at the top of the periodic table, for tin, it's got a 4 charge. Well, sometimes it also has a 2 charge, so you need to watch out for that one. And then oxygen at the top is -2, drop and swap, and then simplify. Okay, so it is very similar to what we've done in the past. Naming them is exactly the same as type 1, except you have to identify the Roman numeral, and that's not as easy. So you're going to name the cation. You are going to name the anion and end it in IDE. The big thing is when you are naming that cation, you have to include the Roman numeral as part of the cation's name. So make sure you do that. Big capital letters there. You might have to do a little bit of algebra. It's not that hard. So practice these. I think that's it. Yep, let's go back. Okay. So I'm going to go through, and I find it easier to go through and do all the writing of the words before I come up with the Roman numerals. So Fe is iron. Cl is chloride. Notice I gave myself some space. Sn is tin. I is iodide. Mn is manganese. Oxide. Notice they all end in IDE. Cu is copper. Sulfide. Cr is chromium. Nitride. Nickel. Phosphide. And then this one, the Ni3P2, is also a nickel phosphide, and this illustrates how important it is to use Roman numerals because they are different formulas, but right now they have the same name. And the last one is bismuth oxide. Okay, now those are all the names. However, each one of these elements is either a transition metal or requires the use of a Roman numeral. So I'm going to go through and I'm going to explain to you how it is done. So I don't know what the charge on Fe is. I'm going to call it X. But I know that when I add it to 3 of the chlorines, it will add up to 0. Because that's why we drop and swap. Well, each of the chlorines is a -1 charge. So what I have is I have X minus 3 equals 0. X is therefore 3. Roman numeral 3. With the tin, I don't know what its charge is, but I know that when I add it to 2 of the iodines, it will add up to 0. Each of the iodines is -1. So when I do that, I get X minus 2 equals 0. X is 2. So you may see, aha, I see a little trick, right? This number and this number. And you would be correct. That trick will work as long as that the anion has a -1 charge. If it doesn't, that trick will not work. And that is illustrated in the next one, MnO2. I don't know what Mn is. I'm going to call it X. I'm going to add it to 2 of the oxygen values, and I know they add up to 0. Well, each of those oxygens is actually -2. So I have X minus 4 is 0. I have Roman numeral 4, not Roman numeral 2. So that little trick where you take this number and you write it as the Roman numeral will work as long as the charge is -1. If the charge is not -1, you can't play that game. All right, so I'm going to show you with this one a little bit different way of doing it. I don't know what copper is. It's X, but there are 2 of them, so I need to multiply times 2. I'm going to add it to my sulfurs. I only have 1 sulfur, and it's -2 equals 0, so I have 2x minus 2 equals 0. If you're careful with your algebra, you would discover that that is x equals 1. All right. This next one is another good example. I don't know what chromium is, but I have 1 nitrogen, and when I add them together, it's going to be 0. Well, nitrogen is -3, so therefore x is 3. Well, what happened here? How come they don't have any numbers at all? Well, if you think about it, it kind of makes sense. 3 plus, 3 minus, when I drop and swap, they both have 3's, and they both simplify down to 1. So you can watch out for that, but you have to be real careful with it. For the nickel, I don't know what it is. X times 3 added to the phosphorus adds up to 0. It is nickel 1 phosphide. For this one, I have 3x plus 2 times negative 3 equals 0. I have 3x minus 6 equals 0. It's nickel 2. And then for the last one, bismuth, I don't know what it is. X, there are 2 of them, added to 3 of the oxygens. So I have 2x minus 6 equals 0. 1, 2, 3. Okay, so you have to pay close attention. You might have to do some algebra, not hard algebra, easy algebra, but just pay attention. And remember, none of these Roman numerals, they're going to be less than or equal to 6. That's as big as they ever get. Never bigger than 6. They might be 6, but that's it.